Hey, welcome back to part 2. So, I made a small mistake. I thought the core package was over, but actually, it is not. What we discussed so far was just the protobufs folder, the protobufs definition. And now we'll move into, let's say, ETH. And let's check it out what is exactly here. So, in the ETH folder, chains, clients, contract. Okay, does not seem to be much. Let's check it out. It's initializing a VM, verify type data parameters, create public client, HTTP, and chains. Mainnet Goerli, optimism Goerli. Looks fine so far. Just a bunch of interfaces. That is a verify type data that goes into the VM public client interface. Verify type data parameters. That's fine. Public clients, L1 public client, L2 public client. Okay, a bunch of initializations for interacting with different chains. Now the chains here are mainnet, Goerli, optimism, okay, the chain IDs that are being generated here from VM and the contracts. Okay, so these are the three contracts: ID gateway, ID registry, key gateway, key registry. I think I put it in some other set of videos. Contracts and protocol we have already discussed. I'll share the or just add the link in description. We'll not get into it, but just I'll give you a quick 2-minute overview that it all starts with your gateway contract. Now this gateway contract is what manages the different registry and verification. This is the ID registry wherein you actually, when you create a new account on Farcaster, an FID is generated. Now this is transfer and change, creation. Where is the creation? Verify transfer. Okay, this is just a bunch of transfer related stuff. 1 second. Why is there only transfer related stuff here? Oh, okay. This is just for interacting with the contracts. These are not the contracts themselves. Yes, if you want to look into contracts, you have to look into the Solidity files. This is the ABIs and then a bunch of interaction on top of it. So here in key registry, and this is primarily for transfer and removal only. I don't know why addition is not present here. Where is that defined? You'll have to check. But if you're familiar with the protocol, I think this should be pretty straightforward to get. So we'll not discuss ETH much. We are more focused with respect to the signers. Let's quickly check in as to what this crypto folder holds. EIP 712.ts. Bytes to hex, verify type data, results async, async result, hub error, verification address claim, Ethereum, username proof claim, public clients, chain IDs. EIP 712, Farcaster domain, Farcaster verify Ethereum address, fix all to minimize collisions. Okay. Verification claim, FID address block hash network. Verification claim, chain IDs, message data. EIP, username, domain, name verification, verifying contract, name registry contract. Straightforward. So whenever you are verifying, this sends it to the verifying contract and eventually verifies your username. This is your username proof. If you are familiar with EIP 712, it helps you create a bunch of structured typed data for sending data packets for even contract verifications and signing. Username proof EIP 712 types. We need to write a domain and a username proof. Message data, verify, verification claim, EOA, externally owned account signature. We provide a verification claim, and then this is what is used to verify it. Result is saying verification claim, contract signature, ETH address claim signature, proof claim, message hash signature. There's a lot happening here. I'll come back to this and see once more. So that was for EIP 712, and this again the same thing will be for ED 25519. Get public key, save sign, save verify, get public key, sign message hash, verify message hash signature. This is an interesting module. I really want to cover it in depth. For the signers, I'm pretty sure this would be requiring a bunch of crypto related stuff from crypto EIP 712. Okay, so we have to do that first. Alright, let's use ChatGPT, my savior, help me out with this particular piece. Now for this, what we need is verifications, username proof, verification address name. First, let's start with this. Verifications. So one folder up // verifications. Solana, make verification address claim, recreate Solana claim message. So far, what do we know? We know that an FID, I as a user have an FID, and against this FID I have a address. For now we'll just go with Ethereum that I want to claim as my address. So for this I need to provide a verification claim. This is all the shenanigans that's happening. So now for this, there are two modules. One is your // verifications, wherein all the code lies, and the other one is inside your SRC crypto EIP 712. These two are coming together in your VM local EIP 12 EIP 712 signer, and this is what I want to understand, because Nenar's managed signer works with this. Anyone who is looking at this and feels confused, make sure you are comfortable with EIP 712. Structured type data, for signature, like what this protocol EIP introduced and how it's used, plus the concept of domains inside it as well. Okay, with that background, let's get started with verifications. Farcaster network and protocol from protocols, that's fine. bytes to base 58. This will be needed for Solana, I think. Dot slash protobufs dot slash bytes. Let's quickly check it out. Dot slash bytes. Bytes to hex, hex to bytes. We from VM base 58. Bytes compare. It takes two uint arrays, takes in their length, and then just compares bytes increment. Uint array input bytes, avoid mutating input, okay. Least significant bytes, and then bytes decrement, bytes to hex string to bytes. Here's a bunch of comparison between bytes and base 54, base 68, big int, etc. Okay, a bunch of util functions. You need to be comfortable converting between these different data types and knowing which one uses what. So primarily, like bytes is just a universal standard or byte string that can be sent and processed by anywhere. But you need to know, such as like Solana requires a base 58, because a lot of strings out there are also base 64, which comes with experience. Now we are getting into verifications.ts. Dot protobufs is not here. I think it's being picked from here. Dot slash, okay, dot slash validate ETH address, validate ETH block hash, validate Solana address, validate Sol block hash. Alright, so the verifications require a layer of validations. Oh, I have low battery, 1 second. It's lagging so painfully right now. Just give me a minute. Now I think it's fine. So where were we? We went into validations and we found out that we need, sorry, verifications, we need validations as well. Hub-Monorepo. Hub-Node.js. Maybe we should go back to core. See, we are checking out verifications, right? Verification requires validate ETH address, validate ETH block hash. Let's check that out. We got all the protobufs. Username type Blake 3. Bytes compare. Got from bytes ED2519, EIP712 from crypto. Okay, validation methods. GS validation. Create a message hash. Taking the message, hash it, and then you sign it. The signing key. Pretty straightforward. Verify signed message hash. Taking the hash, taking the signature, taking the signer, the validation. Validate message hash. Okay, so this is just a bunch of checks that is being run. Hash length, the bit validation methods, EID 259, one and verify validation methods. Here is validation methods. Can verify. Runs a boolean. So let's start with the verification piece of things. Verification. Verifications. First thing that we have is the verification address claim type. Which type of address do I have? Do I have an Ethereum address or do I have a Solana address? Verification address claim Ethereum. Let's say I have an Ethereum address. I need to provide my FID. I need to provide my address. I need to provide the block hash. I need to provide the network. I need to provide the protocol. Right, straightforward. I need to provide my FID. I need to provide the block hash. I need to provide the Farcaster network, like is it mainnet, testnet, devnet, etc. And I need to provide the protocol, which in this case is going to be Ethereum. Straightforward. And most important, I need to provide my address also. 0x123, whatever it is. For Solana, FID, address, block hash, network, protocol. Okay, everything remains the same. Same to same, just that this becomes Solana. And this address might be like a bit different, like something. Okay, now this is the main function. Make verification address claim. How do you do that? You have an FID, you have an address, you have a network block hash protocol, and you return a hub result verification address claim. Switch depending on the protocol. If protocol is Ethereum, then you got to do this. If protocol is Solana, you got to do this. Let's check it out. So you have an Ethereum protocol. Make verification address claim. Now our case is Ethereum. Let's check out what's happening here. ETH address hex. validate ETH address, pass in the address, and then validated ETH address, you convert bytes to hex string validated ETH address. If there is an error, you say ETH address hex dot error. Okay, block hash hex, validate ETH block hash, validated block hash, you convert back to hex string, and then you return OK FID ETH address hex dot value, block hash hex dot value, protocol Ethereum. Validate ETH address, validate ETH block hash. Okay, let's check it out then. So what it does is, inside it calls validate ETH address and validate block hash. How is it like validating the signature? Let's check. Validate ETH address, validate ETH block hash. Okay, protocol Solana. Checks out validate sol address, same thing. Validate sol block hash, same thing. Returns OK. Default return valid request and valid param. There's a message that make verification address claim. There's a signature. What is happening? Let's check it out. To validate ETH address. Now it's time to go to validate ETH address. /validations. Time to jump here. Validate ETH address. So many validations in here. Basically all the things that we saw in protobuf, this is the validation layer for all that. Alright, so what we are looking at here is validate ETH address, like basically these 4 functions. Let's check it out. I provided an address. If not address or address length is 0, bad request validation failure. If it's not 20, it's just a basic length and it's just a basic check whether address exists or the length is there. Okay, ETH block hash same 32 byte block hash. Same would be for Solana block hash. Okay, that is checked for these 2 pieces of information. This just checks for length and null. Okay, this just checks for length and null. It's not doing anything linking or something. This is fine. What happens after it? And then validated sol address, you validated ETH address bytes to hex string. Bytes to hex string would be coming from here. That's fine. Make verification address claim. Yeah, it just checked it and returned OK FID, so on. Alright, there's a hub result verification address claim. Verification address claim. Yeah, it returns this type. What is hub result now? Hub result. Okay, so that's a dot errors thing. Hub result. The result T hub error. Fine, that's again straightforward. But what I did not get is, it is just you pass in these 5 things and you get a check on whether the Ethereum address is valid or not, block hash is valid or not. So good so far. This verifications would be used somewhere else, I think. That is what we'll need to find. So we have seen most of these factors: index limits, time, username, validations. Okay, all these utils are covered. Then let's get into the crypto folder. Bytes to hex verified typed data from VM. What does verified type data do from VM? Type data was signed by the provided address. Verified type data that was signed by an EOA, verify message on contract accounts, is public client dot verify message action. Alright. This makes it a bit clearer. From name cow wallet to warmware contents hello world is constant signature. Sign type data from the account. Domain types private type message valid. Verify type data. Address is account dot address. This is a signing account. Domain types private type mail message and the signature, and it will return it. Fine. This is the message. So this is the key function. Hub async result, hub error, verification address claim. Verification address claim Ethereum. Straightforward. Just those 5 keys that we talked about. This one. Username proof claim, not doing that right now. Default public clients, each clients. Initializing the clients using VM and the chain IDs. Now let's quickly do this. EIP 712 Farcaster domain. Pixel to minimize collisions. Farcaster verification claim. The structure we are providing. FID address block hash network. FID address block hash network. Protocol is automatically Ethereum. Chain ID is in 0. Farcaster message data. Hash and bytes. EIP central username domain. Okay, this is for the username. We are not concerned with this piece right now. Message data. Okay, verify verification claim EOA signature. I think this would be the function. Contract signature verification, ETH address claim signature. Signature, username proof, message hash, right. These are the bunch of functions. So verify verification claim EOA signature, verify verification ETH address claim signature. Okay, this is the highest level function. It differentiates between EOA and contract, and then we'll call the relevant functions. Let's check it out. This kind of flows into verify, verification, ETH address claim signature. This takes in your verification address claim, verification address claim, which in turn has the 5 keys like your FID, the 0x address that you have claimed, block hash, and so on, the 5 things that we talked about. And it takes in a signature also. It takes in an address, takes in a verification type of 0, chain ID of 0, public clients initialized by VM. If EIP 712 Farcaster verification claim chain IDs, if the chain ID is not available, then it will request, hey, I don't know which chain ID you're talking about. If verification type is equal to 0, by default it takes in an EOA, send it there. If otherwise, you make it a contract signature, else return invalid verification type. Great. So this, based on whether it is 0 or it is 1, this further calls in verify ETH address is an EOA, like verify this signature, and if it is 1, it basically calls in contract. Fine. Now getting into this, let's assume it's an EOA signature. What does it do? You put in the claim, you put in the signature, you put in the address, you put in the chain ID. If chain ID is not equal to 0, it will reject. Invalid chain ID. No problem. Verify type data, what we have seen. Verify type data. It will take in the address, bytes to hex. It will take in the domain. It will take in types. Verification claim is a EIP 712 Farcaster verification claim. Let's check out what is EIP 712 Farcaster verification claim. Okay, this is the structure. Oh, nice. It passed in the type. Just a verification claim. Primary type is verification claim. Message claim as verification address claim Ethereum. And the signature. We are not signed anywhere. We need to sign outside from that address and provide it to this function. Okay. So this verified type data, the opposite piece we'll need to provide in this one. Sign type data and provide it here. With the verification check. Pretty straightforward. Now the other side, if it's a contract thing, you need to do verify type data, address, domain, type, signature. Same thing for the contract one, right? So it provides in your ETH address claim the signature and the address. This is where you do the sign type data and provide it here. Then call this function to verify this. The two-sided process. This comes from user end or any application that is doing this. Oh, right. Same thing for contract. So address claim signature, EOA, contract. This is done. Providing this address, the structure from the type data structure for verify type data to figure this one out. Primary type is mail. Okay, so it automatically knows the structure of mail. There and you have to provide it. manually. Data domain types. Oh, right. This is what is being provided. Types we provided mail. It automatically picks this up. Fine. So this is okay. Read a crypto EIP 712 का signature verification. Straightforward. Signature address. But the thing here is, what is the claim? The claim here. Okay. The claim was the body itself. Oh, right. So the claim was this entire packet itself. Alright, alright, alright. Now I finally got it. Apart from the protocol piece, rest 4 of this. This is the claim. Claim is my FID is this, block hash is this, I am calling for Farcaster mainnet, and the address that I am claiming is this. This entire thing gets signed by address, and then this gets verified. Once this is verified, your FID is associated with this particular address.